Well, thank you everyone for joining. And thanks to Linaro for hosting this remote session despite the situation. I'm Matteo Carlini. I'm the Director of Software Technology Management at ARM in the Open Source Software Group.
Hi, I'm Shebu Kriakos. I am also one of the technology managers in the Open Source Software Group.
But today we are here to represent the TrustedFirmware.org Open Governance Community Project. So bear with us for the next 25 minutes. We are going to give you a few updates and all the exciting news around the project. And trust us, there are a lot of good news. So let's start with a slide full of headlines. So these are all headlines which made the news in the past couple of years regarding security vulnerabilities. You might recognize some of them in the middle, very popular ones. But the key point I would like to make is that there are all sorts of vulnerabilities across all the possible devices which we interact with every day in our life. There are IoT devices, cameras, smartphones, cloud services, as well as cars. Can be autonomous cars and also the traditional manual cars. So this is a very generic slide, but if we go a bit more in deep and we see the firmware vulnerabilities that are extracted from the NIST vulnerability database, you can see that firmware is increasingly becoming the preferred target for all the attacks across all the systems. So this is a picture over the last 20 years, and you will see the increase. So why that? So there are many reasons for this increase. One could think about operating system kernels, applications that are getting more robust, connectivity protocols that are implementing new features and new handshake mechanisms. So the attackers are trying to target lower in the stack, and they are reaching out to the firmware. But the other important reason, the key reason for me, is that the firmware is the highest privileged piece of software in all our devices. Higher privilege than any kernel, than any hypervisor. So effectively, if you own the firmware on a device, you own the device. But don't be afraid, don't be scared, there is hope. There is always hope. And we strongly believe that the hope must be built on top of collaboration. Sure, if I can move this, right. Collaboration. Collaboration because security challenges are complex. Think about Spectre. So how long would it take to properly understand what the Spectre attack is really about? And how long did it take to the industry to react to Spectre and find the proper security workarounds for the Spectre attacks? But it's also a security by scale problem. So if you look at the right side of the picture, these are all the industry vendors from the IoT market in 2019. So it's really an economy by scale exercise. We need to develop security fixes that can be deployed and applied across the whole ecosystem. And this can only be done, from our point of view, through through collaboration. Because collaboration is the key to solve the complexity of the security problems and really to create one solution in one single place that solves the security challenges once and for all the ecosystem. And that's the main reason why we created Trusted Firmware as a platform, as a community platform to build security in a collaborative way. So Trusted Firmware is an open governance community project which provides a reference implementation, all open source, of the secure world software for ARM processors and ARM-based platforms across all the market segments. It's open governance in the sense that its membership is open to all, and the governance is transparent and is overseen by two main bodies. On the left side, you will see the board of directors from the project members, which decides on the strategic direction and financial direction of the project. And on the right side, you see the technical steering committee, which decides on the technical direction. So how is the collaboration going? Because we talk about collaboration, Well, I would say it's going pretty well. So this is a visual representation of the external contributions that we see coming into the project from the ecosystem. So this is a count of the contributions that are not from ARM, but are from the ecosystem over time since the beginning of the project. So we take as a starting point 2013, when ARM Trusted Firmware was launched. Now it's not called ARM Trusted Firmware anymore. Now it's called Trusted Firmware A, or TFA for friends, for the application processor. Initially, clearly, the contributions were set to 0 when we started. And then slowly over time, contributions started to increase. In 2016, the first improvement, we removed all the legal paperwork and the need for having a signed CLA in place for being able to contribute. So since then, since 2016, we accept all contributions under the terms of DCO. And the license has always been a permissive BSD free close license. And then continuous improvement up until 2 years ago, 2018, with the launch of Trusted Firmware M for all the microcontroller space. A few months later, in the autumn of 2018, with 6 founding members, we launched the TrustedFirmware.org community project. And the increase of collaboration continued up until last September 2019 in San Diego, sunny San Diego. Back at the time, we were all available to travel. So we announced that OPT was also joining Trusted Firmware to continue the collaboration and to enlarge the family of projects which are part of TrustedFirmware.org. So in terms of contributions, only taking into account the last couple of years, there has been an increase of more than 120% of contributions, with peaks that reaches half of the contributions coming from external partners versus ARM in specific time periods. So it's really going well. It's really a success story about collaboration. But we're not stopping here. The family is expanding, the family of projects being part of TrustedFirmware.org. So we are very, very pleased to announce today that Hafnium is joining the Trusted Firmware project. So now, what is Hafnium? Hafnium is a project that was originally started by Google, by the Google Android security team. ARM and Google have been collaborating around Hafnium for the past couple of years. Hafnium comes into Trusted Firmware as a reference Secure Partition Manager for the systems which implements the Armv8.4 Secure EL2 virtualization extension. And that's on the application processor. I'm talking about the application processor side. Hafnium comes with a minimal code base, so with very reduced attack surface. It enforces the principle of least privilege, and it adds an extra layer to the defense in depth concepts on our trust zone software space. And in terms of use cases, it enables the isolation of one of multiple trusted execution instances running behind trust zone. So if we look at the picture, so here on the left side, it's a traditional system which are not Secure EL2 enabled. So these are not 8.4 systems. And we are transitioning towards a system like this, in which above Trusted Firmware A, there is Hafnium SPM, which allows multiple trusted execution environments. There is a link to the initial code base into tf.org. And the other good news is that Hafnium is joining with the same licensing scheme as the rest of the Trusted Firmware project. So a permissive BSD license. So let's have a final look, a deeper look at the software architecture that we are now building then on the application processor side, on the A-class processors. So on the picture, you will see all the blue boxes will be provided as a reference, open source, from the TrustedFirmware.org project. So starting from the EL3 runtime firmware, which is the traditional Trusted Firmware A, going above Hafnium SPM running at SEL2, and on top, we provide the reference given by OPT as a trusted OS with its own trusted applications on top, which might also implement PSA secure services. And then partners and ecosystem can implement their own specific trusted OSs, their own specific platform services, which are all isolated one another thanks to the virtualization extension. So we are really achieving isolation through virtualization in the secure world. And the other point I would like to stress is that Trusted Firmware, all these components will implement all the standard interfaces which are defined by the ARM PSA firmware framework for the A class, which is most friendly known as the SPCI interface. This is really key because we strongly believe that the key for a smooth transition into a more secure firmware space goes through the standardization of the interfaces between the normal world and the secure world. So we strongly encourage our partners to adopt the standard interfaces defined in the ARM PSA framework. With all of that, we will be able to achieve defragmentation of the secure firmware space, both at EL3 and an SEL2. And what we gain out of that is the integration for our partners, the testing processes, to provide a way for updating the firmware in a standard way, which again is useful to fix the firmware vulnerabilities in field. And we ease the process of auditing and security assessment of devices. So eventually, I move this thing around again, we increase the security of our devices and we achieve firmware transparency, ultimately reducing the time to market and the development cost for the entire ecosystem. And with that, I'm passing over to Shebu for the continuation.
Hi, everyone. Hope you can see my screen now.
Not yet. Now we can.
Hi, everyone. I would like to get started by briefly mentioning about Trusted Firmware M, which is one of the projects in the trustedfirmware.org project portfolio. Trusted Firmware M provides a secure processing environment for Cortex-M devices that today powers millions of IoT endpoints and embedded applications. It is a reference implementation of the platform security architecture, and it provides a secure boot that authenticates the runtime images, and it provides a standard set of runtime secure services such as storage, crypto, and attestation that is made available through the standard PSA APIs. The TFM project has been launched for the last 2 years, and in the last 2 years, it has come a long way. For example, it has provided as the root of trust for a long list of silicon platforms and RTOSs to be PSA certified under the PSA certification program. The project started off by supporting a bunch of ARM reference platforms, and now the supported platforms are in the increase, starting off with the Cypress PSOC 64, which is now supported upstream in TFM, and there is active work going on to upstream more V8M platforms such as the NXP LPC55 and ST's STM32L5. The project is also starting to integrate with a lot of open source RTOSs. So early on in 2019, we started off with integrating with EmbedOS, followed by Sapphire. And later on in 2019, we started integrating with the Amazon FreeRTOS and RT-Thread. And the aim by providing such an ecosystem of TFM on different silicons and on operating systems is to provide IoT application developers to avail security services from Trusted Firmware M, thereby making IoT endpoints more secure. And I'm glad to say during this month, the project is achieving a great milestone by providing the TFM 1.0 release tag. So this is a culmination of the work from the TFM ecosystem over the last 2 years to implement and align to almost all the PSA specifications, means mostly around 1.0, meeting all the PSA certification requirement, and thereby being the root of trust for a large variety of Cortex-M devices. And I would say this is just the beginning, and there is still an exciting roadmap ahead for this project. For example, providing different TFM profiles for different memory configurations, supporting a lot of V8M platforms, etc., etc. So I would say watch the space. Now we have briefly looked at a few trusted firmware projects that ensure security in end devices. But nowadays, most of these devices also needs to establish secure links to say connect to cloud or any other end applications. Mbed TLS has been an extensively used TLS library to provide secure, authenticated, and encrypted connection over unreliable networks. What the TLS library basically does is abstracts away all the cryptographic certification management and authentication complexity that's associated with the TLS protocol away from the application. And so far, the Mbed TLS project was available under the ARM GitHub as an open source project. And today, I'm glad to announce that the Mbed TLS project is transitioning to become a trustedfirmware.org open governance project. And this move is being made with the sole aim to take this project even to be a far well adopted community project where the strategic and technical direction of the project is driven by the trustedfirmware.org members. The project continues to be available under the Apache 2 license. And today, if you go to the trustedfirmware.org website, we have gone live with a new Mbed TLS mailing list that would be a good starting point for the entire ecosystem to collaborate on future enhancements on the Mbed TLS project. One of the associated activities that has been happening with within Mbed TLS over the last several months has been to basically split the Mbed TLS project into two halves. The Mbed TLS project providing all the TLS network security aspect and the X4 509 management, while the second part of the project called PSA Crypto, bringing together all the crypto primitives in the Mbed TLS library and making it accessible through a set of PSA crypto APIs. This second project has been driven by the Platform Security Architecture program, aiming to provide a crypto library that devices can use for different purposes, such as securing the valuable assets in their system, to establish secure connections, and to securely provide secure updates to the end platforms. For example, usage model on a Cortex-A or Cortex-M devices, as shown on the right-hand side of the screen, would be the PSA crypto library being on the trusted execution environment or the secure world, and applications or Mbed TLS for that matter can avail cryptographic functionality from the PSA crypto library through a standard set of PSA APIs. In addition to the developer-facing API, the project is also starting to define a set of low-level APIs that would enable the library to interface with a huge array of secure elements and accelerators. I would say the project is still in its infancy. There's a long way to go, but we have in the recent months seen a lot of momentum in silicon vendors trying to adopt this library because it brings standardization around these APIs. So I'd like to request you to have a look into this project under trustedfirmware.org. Now, very quickly, we have gone through a bunch of projects that trustedfirmware.org today host. So traditionally, it has been a hosting place for TFA and Opti, which together so far has provided the trusted execution environment for Cortex-A devices. With the advent of Hafnium, it's going to provide a secure hypervisor for future Cortex-A devices. TFM, of course, provides the secure processing environment for Cortex-M devices. The MBTLS project ensuring you can establish secure connections from these endpoints. PSA Crypto providing a crypto library with some standard PSA Crypto APIs. So we truly believe that trustedfirmware.org is providing that collaborative platform with a complete and coherent set of open source secure software solutions that can be deployed across the ARM ecosystem. Now that we have looked at the different project that tf.org hosts today, I would like to briefly touch upon how does the project operate. So as Matteo was saying earlier on, it has got a board which sets the strategic direction of the project, and the technical steering committee is responsible for the technical direction of the project, the code base, the maintainership, and the different technical topics. And during 2018 and during 2019, we had all these great members collaborating under the trustedfirmware.org board and the technical steering committee to lead these different projects in terms of strategic direction and the technical direction. And we have got new members joining the project as well. And today I'm very glad to announce that Renesas and NXP is joining trustedfirmware.org as its latest platinum members. We are sure that with the huge experience and expertise that Renesas and NXP has over the years in creating ARM-based secure devices, it will be a huge value add for the project for these two companies to work under trustedfirmware.org to set the future direction of the project. So welcome Renesas and NXP. As we come to the close of this session, I would like to quickly go through what is the collaboration on a day-to-day basis as far as the project goes. So there are, as we talked about during the keynote all along, it's all around open collaboration. So any new idea starts coming up through the mailing list. So each of these projects have got its own mailing list. A lot of people are registered to it, and now it's becoming a very busy place where there are a lot of conversations around new designs and problems that people are facing once they're deploying these projects in end devices. Then we're starting to have bi-weekly open tech forums, which is normally attended by 40 to 50 people for each of these areas, where main technical topics are brought up by key experts, and these are presented, and then follow-up discussions are being held. We are also starting to have an annual workshop for some of the key project areas. So it started off with a TFM workshop back in October in Lyon, which had around 36 people attending a 2-day workshop discussing quite a lot of key TFM technical topics. And we hope once the travel restrictions are lifted, we can have similar workshop for other projects as well in the coming years. So once these design ideas are firmed up, the patches comes in the trustedfirmware.org get it for open reviews, giving a chance for everyone to have a look at the code and review the code. And once it's all gone through the review cycle, it finally gets hosted in the trustedfirmware.org Git. From there on, it's available through various open source licenses for consumption to end devices. And to complete the cycle, we are also starting to have an open test system, which we call Trusted Firmware OpenCI, which is available in this link, where we are trying to make sure that all the member platforms are always tested and up to the mark with the latest code bases for each of these projects. So by starting with design, which starts out in the open, going through development, reviews, and testing, tf.org provides that complete open collaborative development lifecycle. So as we come to the end of the keynote, I would like to conclude by saying that innovation is exploding in all aspects of our lives, whether it's artificial intelligence, autonomous machines, 5G networks, cloud computing, mobile devices, or even IoT networks. And what I'm showing on the right-hand side is some of the major challenges that has come out in the major cybersecurity reports, showing there are going to be a lot of challenges in the cybersecurity space in the coming decade. But one of the very recurring themes in many of these reports is, of course, the complexity of security is ever in the increase. We are going to see an increasing skills gap in trying to solve some of these challenging security issues. Of course, the vulnerability and attack surface is ever in the increase. And if we combine this data with what Matteo was showing in the beginning of the presentation around the NIST database number, about the number of firmware vulnerabilities that has hit us during 2019, and it hitting a record high during 2019, we think it's quite essential that the ARM ecosystem that is going to create the next billion devices should definitely come together, bringing all their expertise under the trustedfirmware.org umbrella to make even more secure devices during the coming decade. And with that, I would like to conclude the presentation, but just remind everyone to stay safe and secure as we go through some of these challenging times. Please do visit trustedfirmware.org. Please do get yourself registered to all the mailing lists so that you can become part of the collaboration right from design, implementation, and testing. Thank you very much.